national and international journals, seminars, and edited 1 technical volumes. On invitation, Professor Shivashankara has visited Malaysia, Nepal, Canada, USA, Singapore, Sri Lanka, and Thailand to share innovative actions for water and atmospheric pollution. He was a professor in Civil and Environmental Engineering, PES College of Engineering, Mandya. AICTE Monitoring Committee has evaluated the progress of the research project carried out by the professor and has awarded the Grade B Good Performance. He has been honored for research contributions by PSCE Mandya on the occasion of Golden Jubilee Celebrations 2012. Professor has guided 4 PhD and 31 MTech students. He is presently guiding 5 PhD students. His research projects are funded by AICTE and VTU on atmospheric deposition and effects of groundwater, climate change, global warming, solid waste management, on-site sanitation systems, and has been active with a number of NGOs in the field of environment and practical consumer awareness on afforestation and soil conservation, rainwater, rooftop harvesting, groundwater management, importance of water quality and quantity, its impact on health. I hereby welcome Dr. Durga Prashant L. and Dr. G.P. Shivashankara to the program. Welcome, sir.
Thank you, madam.
Thank you, Professor Ranjita.
Yeah, I now request the chairpersons to take over the session.
Okay. Sir, start, sir. Durga Prasad, Dr. Durga Prasad.
Yes, sir. We can start.
Yeah.
Yes, sir. Am I audible? Hello?
Yes,
Hello,
sir.
audible.
Yes, sir, you are audible.
Okay. So we shall start off the session.
How will you start?
Yes,
Hello.
sir, you
Yes,
can
sir.
call the first paper,
Sure.
sir.
Yeah. Good afternoon, everybody. In this session, there are 4 authors are going to present the paper on different topics. Already introduced by our Professor Ranjita. Now, first paper, that is effect of water quality and strength of concrete. That is, author name is Brunda GS and Syed Pras Siddiqui. So I'll request Brunda or Syed Prezi will take 15 minutes and present the paper. Yes, start.
Very good afternoon, respected judges. This is Syed Faraz Siddiq from Acharya Institute of Technology. I hope you can see my screen here. Is it visible, sir?
Yes, visible.
Done.
Yes, it's visible.
Yes, very good afternoon. Other than the judges, the attendees, very good afternoon to everyone. So our topic of research was with respect to effect of water quality on strength of concrete. So these were the various places where we collected water. One was the potable water, one was sewage water, one was sewage water after treatment, one was Chikbanawara Lake water, and one was Hesargata Lake water, which is nearby to our campus. And these are the contents what we will be discussing in today's presentation. So the complete abstract of this respective research work was it was completely with respect to effect of different qualities of water on concrete strength. So we basically decided to go with M25 grade of concrete with cement ratio, water to cement ratio of 0.5, and water samples such as potable water, sewage water before treatment and sewage water after treatment, Chikbanawara Lake water and Hesargata Lake water were collected from various sources near the college campus. And we casted cubes as well as cylinders in order to check the compressive strength as well as the split tensile strength for the same. And we have prepared the cubes for 7 days, 14 days, 21 days, and 28 days. So this was the methodology which was followed by us. That is, we collected the water samples from different sources, and we have a wastewater treatment plant here in our campus. So we got an opportunity to go there and collect the sample. Okay. After that, testing of samples physically and chemically and the biological parameters were tested in the laboratory, and collection of materials what are required with respect to concrete, like coarse aggregates, fine aggregates, cement, were tested. Basic tests were conducted on these type of materials. Then we designed this M25 grade of concrete we casted the same grade of concrete with different samples of water. Then followed by we checked the compressive strength and the split tensile strength of the concrete specimens. And these were the few tests which were conducted by us. That is, specific gravity of fine aggregate we found across 2.64, and coarse aggregate was somewhere across 2.79. With respect to cement, it was 3.15. And these were the biological tests or the environmental tests that were conducted with respect to the waters. As you can see, we have potable water here. We calculated these important parameters such as pH value, total hardness, chloride, nitrate, total alkalinity, dissolved oxygen, acidity, COD and BOD were evaluated for different samples of water which we had collected. And these were the results what we had got. And these are the results what we obtained for 7 days. As I mentioned in the starting of my presentation, my concrete was designed for 25 Newton per mm square, that is M25. My target mean strength was somewhere across 31.6, as my standard deviation is 4 for M25 grade of concrete. So this was the compressive strength what we achieved for potable water. For 7 days, we found out that the potable water compressive strength was more, whereas in case of the split tensile strength, also the same thing, the potable water had a higher split tensile strength of concrete. Then with respect to 14 days, we found out that again potable water has the highest compressive strength, followed by the same with the split tensile strength of concrete. Then similarly, we have done it for 21 days and 28 days as well. You can see the values what we have got for potable water, sewage water. But I want you to focus a little bit on to this respective lake, that is the Chikbanawara lake water, where we have got very less compressive strength as well as the split tensile strength in all the cases. Yes. So this is the final 28 days compressive strength and as well as the tensile strength of concrete. And we achieved somewhere across 24.93 Newton per mm square of my compressive strength with respect to potable water. And Chikbanawara lake water slightly was increasing, but it was not near to the other waters which were collected and which were used for used as a medium for my concrete mix. And this is the graphical representation of the same tabular column what we have seen there. This is graph with compressive strength and curing days 7, 14, 21 and 28 days. So the green color here represents the Hesarghatta lake water, blue is the potable water, and maroon here is the sewage water after treatment, and purple here is sewage water before treatment, and light blue here is Chikbanawara lake water. So you can see here the Chikbanawara lake water is slightly increasing, but it is not competent enough to the other type of water or other different waters which we have collected. And this is a graph of split tensile strength with respect to curing ages. This is also the same thing with respect to the Chikbanawara lake water, what we have got. And in the graph, we can see that potable water has the highest split tensile strength as well as the compressive strength. And here we have plotted separate graphs with respect to each and every parameters what we have evaluated. Let me go back to the first slide. Yes, with respect to each and every parameters here, that is with respect to potable water, sewage water, and all these things. With these parameters, the pH value, total hardness, chlorides, nitrates, total alkalinity, all these parameters were plotted here with the compressive strength, as well as with respect to the split tensile strength. So here we can get a proper idea about how we have got the graph. So this is with respect to compressive strength and nitrate content into the water. This is total hardness what we have calculated. So you can see the variation, how the variation is happening here from potable water to the sewage water to the Hesarghatta lake water, followed by the sewage before treatment and Chikbanawara lake water. And the conclusion with respect to this research is the concrete specimens were made of different water quality samples. Like I have told you, we had used potable water, sewage water before treatment and sewage water after treatment, Hesarghatta lake water, Chikbanawara lake water for these many durations, that is 7, 14, 21 and 28 days. And we saw that there was strength which was at least 90% equal to the potable water. But when we saw the Chikbanawara lake water, it was very less. And the compressive strength obtained for concrete mixed with potable water had 13.5% more strength than the cubes made with Hesarghatta lake water. The concrete made with sewage water after treatment had slightly less 28 days compressive strength compared to Hesarghatta lake water. From present study, we understood that slightly acidic, alkaline, salty, brackish colored or foul smelling water should not be outright rejected. Because if we do not have any other sources of water which we can use for our concrete, I should not reject it outright. We should try to treat it, and we should try to understand what are the biological or the chemical agents that are present into the water, and what will be the aftermath effect onto my reinforcement. It might be with respect to the reinforcement, or it might be with respect to the concrete. And the 28-day compressive strength of concrete specimen with treated sewage water is less percentile than compared to that of the Hesarghatta lake water. And the concrete specimens with untreated sewage water and Chikbanawara lake water has 30% less compressive strength. As you can see, untreated and Chikbanawara lake water has, we'll just go back to this. Sewage, yes, not this thing. Yes, sewage before treatment and Chikbanawara lake water. You can see this, it is 30%. It is 30% less. Yes, 30% less compressive strength than compared to that of the potable water and treated sewage water. And the scope for our respective research here is we can also prolong this research work with respect to the how deterioration will happen with respect to my reinforcement, and what is the behavior of my concrete. Is the passivity layer onto the reinforcement compromised? Does my the chemicals which are present onto my present in my water are going to affect my passivity layer which is there onto my reinforcement? Will it corrode? Okay, all these parameters can be studied, and the water qualities of other streams can also be studied. So this was our research work, and these are the references which we have followed. Thank you so much.
Okay, thank you.
Thank you, sir.
Thank you, Syed Siddagi.
Thank you, sir.
Maybe some questions will maybe ask at the end of the session also.
Definitely, sir.
For
Definitely,
our this one.
Yes,
Be ready for that.
sure,
session.
sir. Sure.
After then, you'll be always. Yeah.
Thank you so much, sir.
Thank you. And next one is second authors. Okay. One minute. Come in. Second author is Sasank BB and Karthik M also. So, paper presentation by the Sasank and Karthik. He is going to give a presentation on the topic of waste plastic as a replacement for coarse aggregate in concrete, a review of literature.
Hello?
Hello. Yes, you start, Shashank.
Yes, sir.
You take only 15 minutes, 1-5.
Sure, sir. Very good afternoon to the delegates of the conference, the chair of the session, and all my beloved fellow participants. My name is Shashank. I'm the author of the paper, Waste Plastic as a Replacement for Coarse Aggregates in Concrete. This is basically a literature review. And this is co-authored by Mr. Karthik M. So as the outline goes, it starts with the introduction, a brief introduction, the purpose of this paper, and ending by the conclusions and the references. So as the introduction, as we know, the word plastic was derived from Greek, which actually means molded. So because of this very nature of the plastic, nowadays the plastic is very useful and it is used widely because it can be molded and it is very light in weight. So basically the plastics are of two categories. One is the recyclable plastics, which includes PET, HDPE. So these are the types of plastics, whereas the other category is the non-recyclable plastics, that is the multi-layer or laminated plastics, which we usually see in our switches or so. So now, as we know, due to the rapid industrialization, the urbanization, the amount of waste plastic generation is increasing day by day. As the consumption is increasing, the waste is also increasing with that. So, and this is a very major problem to the environment. Moreover, as we can see everywhere, the waste plastic, which is uncollected, it is blocking the drains. It is spilled all over the empty places, which is not very good for the society and even as the health aspect of animals and people around. So to overcome this issue, many efforts were taken, many policies have come, but in practical, we don't see much of it working. So now the purpose of this paper actually, it was to map out the recent research trends in incorporating waste plastic as a replacement to the natural coarse aggregates, and to put most of the literature which is concerned to the waste plastics into at one place so that it's easy for the researchers to have all the information like within a click, and to understand the level and progress of research done in this particular field and what needs to be done in future. As I was doing my MTech thesis, it was very difficult for me to collect all the literature, go through it and find the gaps. It was quite difficult. So this actually made me to do a literature of this topic. And also it helps for the policymakers in case when they need to consider. So the information gathered will be easy for them as well. So now the sources from where the literature is collected, the main criteria was that research papers were collected from open access journals and which are peer reviewed only. On the other hand, the paper which is considered in this literature has to be cited. The keywords through which the papers were collected were waste plastic generation, the concrete, and plastic coarse aggregate. So based on these these keywords, the literature which was available was collected. So we'll go for a brief idea of what is the waste generation of plastic is in India. This is as per the Central Pollution Control Board estimates, which says that India generates close to 62 million tons of municipal solid waste, out of which 8% is of plastic. So we can see as the calculation goes, as the report of 1718 of CPCB, India generates approximately 9.4 million tons of plastic per annum, which is quite huge, of which 5.6 million ton is recycled, whereas 3.8 million tons of waste plastic is left uncollected. So which accounts to around 9,400 tons of waste per day. So we can see this is a huge problem. So this is a pie chart which shows the consumption of different virgin plastics. Whereas HDP, this is the high density polyethylene, which is around 17%, whereas LDP, LLDP is at 19 and 6%. So as this pie chart goes, we can see HDP, LDP, and PP, PVC are major plastics which are being consumed. On the other hand, in this pie chart, we can see the percentage of classified waste plastic generation. Here, 66%, more than 50% is the waste plastic generated is of HDP and LDP. And whereas 9% is of PET, that is the bottles which we use, the drinking water bottles or the soft drink bottles. and the 10% is of PP, polypropylene. So if we consider PET, HDP, PP, these three together makes more of around 80% of the waste plastic generated. So this is a graph where we can see the per capita consumption of plastics in kgs. Compared to the developed countries such as America, the countries of Europe, we can see India per capita consumption of plastics is very less, whereas USA, Europe, it is around 109 kgs. Europe is at 65 kgs per capita consumption. So this graph actually shows that compared to the developed countries, the developing countries or the underdeveloped countries use plastic less. This may be for various reasons such as the government policies or the availability, the usability. So the summary what we can get from this is like HDP, LDPE materials, which constitute about 80% of the waste produced. And it can be noted from the report that developed countries use plastics more than the developing countries, again for various reasons. So now, based on the literature studied, we'll see how the waste plastic aggregates can be produced. So basically, there are two methods. One is the manual, one is the mechanical. In the mechanical, as the flow chart goes, in the beginning, there is segregation of plastic, and then there is washing and drying of the plastic. After which, what happens in the manual method is the plastic is melted on a stove with a pan or a utensil kind of thing at temperatures which is not controlled. So once the plastic is melted, the liquid plastic is casted in, it is more of a chunk of a plastic is formed. So after the plastic is cooled, the plastic chunk is broken down. What happens here is the broken plastics which are to be used as aggregate are not uniform in shape. There is no control over the shape of the aggregates. Whereas in the mechanical method, after the segregation is done, the washing and drying of the plastic is done, the plastic is melted at a high temperature in a controlled environment, in a proper machine, which is called the extruding process. Whereas the shredding of the plastic after it is cooled into required sizes is done in a sieve, in a cutting machine with proper sieve shapes and sieve sizes, which helps us in quality control of the aggregate shape and the size. And so these are the basically two methods in which the aggregates can be produced. And whereas mechanical method, it is fast and it helps in producing good quantity of aggregates in a very short period of time. So as the literature is collected, we can see the tests that are done on the aggregates. So this is the chart wherein the properties of waste plastic coal segregates is shown. As we can see, almost all the parameters of the tests are within the range of the natural aggregates. Or the LDPE plastic, only the LDPE plastic has elongation index and angularity number beyond the limit of the natural aggregates because of the property of the LDPE, which is very difficult to mold as it is quite soft. Apart from this, almost all the parameters are within the limits. As you can see, the impact test, the aberration test, they're literally zero. It does not have any effect on the plastic aggregates. Now coming to the application part, the literatures, all the studies done, they have suggested for non-structural elements such as low side building, cementitious backfill, it may be possible to use such concrete in its application which are exposed to severe chemical attack. This is mainly because plastic does not react with the chemicals, whereas we can see our aggregates with different mineral properties, they sometimes react with the chemicals in the air or in the water. And on the other hand, it is basically, the researchers have said that the concrete made up with particular amount of plastic aggregates can be used only for non-structural or low strength concrete, because it's not possible to get very high strength of concrete with the plastic aggregates. You can use the concrete with plastic aggregates as curbs or medians in highways, as a footpath, which basically does not have much of a load on it. So the conclusion what it is derived is, from the following literature it can be studied and concluded that waste plastics can be used as a core segregate in concrete partially, because 100% is not possible. One of the major reason is there is low bonding between the plastic core segregates and a cement paste, which leads to the low interfacial transition zone. All the researchers, it was more of an unanimous thing that not more than 20 to 25% of the plastics can be replaced. So which gives us an idea that we have to develop methods, or we have to try hard to increase the percentage of replacement of plastic aggregates. On the other hand, the aggregates made up of different category of plastics has minimalistic impact on the strength of concrete. So be it HDP or be it PP aggregate, so the category of plastic does not have much of an impact on the concrete. The volumetric substitution of plastic core segregates is the optimum way of replacement than grade substitution. And few researchers who have tried to increase the strength, they have got a bit of a success when they have used super plasticizer or mineral admixtures. So which also gives us an idea that using super plasticizer or mineral admixtures may give us better results, whereas more research has to be done by the different combinations of the mineral admixtures or the super plasticizer in the concrete. Now, the concrete made with plastic core segregates can be used in non-structural elements, curbs, medians on highways, footpaths, etc. So basically, a non-structural or low strength concrete. So these are the references I have used in this work. So it is around 15 literature papers, 2 of report from Central Pollution Control Board, that is Ministry of Environment and Forest. Thank you so much. And here I end my presentation, sir. Thank you so much.
Thank you very much.
Sir, you can invite
Hello.
third
Hello.
Yes, sir.
Thank you.
Welcome, sir.
Next presenter is Satvik and Krishnaraj. They are going to present a paper on the topic of application of CRM technique for predicting the consequences of labor, sleep, deprivation in construction projects.
2020, sir.
Satvik, you'll take only 15 minutes and present a paper.
Yeah. Good afternoon, sir. Can you hear me, sir?
Okay.
Can you hear me, sir?
Yes, you're audible. Go on.
Audible.
Yeah. Good afternoon. My name is Satvik. My topic is application of CRM techniques for predicting the consequences of labor sleep deprivation in construction projects under the guidance of Dr. L. Krishnaraj from SRM Institute of Science and Technology. First introduction. As in construction, labor is the most important process as it involves human performance a lot. And then the labor productivity majorly affects by two things. One is the type of the project and size of the project. And labor in all the countries, labors are very much huge in number, due to which their health and their psychological behavior and sleep deprivation will be affected because they work overtime and they don't care about this importance of the health and sleep deprivation, which affects the professional life. Like countries like Japan, South Korea, India, USA, they do not get sufficient sleep of 7 hours. Then this is a pictorial representation of a person who is sleep deprived at said. There are major factors which are affecting the labor productivity, such as technology, labor organization, management, real wage trends, working hours. But one of the major factors which has been considered for my research is sleep deprivation. What do you mean by sleep deprivation? Sleep deprivation is defined as loss of sleep or insufficient sleep, which results in poor concentration, irritability at site. Means if you're a person who is sleep deprived or labor, he will tend to make mistakes or he will lose concentration at work. It will lead into fatigue or accidents. It also not only affects us physical, it also affects us mental status. That will relate to his work environment and his personal life also. This is a labor productivity of a chart. So how does it vary from the recent years? Then the problem statement. The effect of shift workers will gradually decrease the productivity growth in the daily work. How does it daily affect the labor's shift workers? That will be considered. The shift workers of labor in construction reduces the both quality as well as quantity of sleep. The lack of communication and knowledge will affect the productivity in construction. Poor health of laborers and improper planning will affect the productivity. Lack of attention of contractors regarding sleep of laborers. The objective of my study is to identify the different parameters of sleep deprivation, to collect the data from different methods and analyze them, to suggest the amount of sleep required among the laborers in construction, to obtain the improvement of labor productivity in the construction industry by reducing the sleep
Mr.
deprivation.
Satvik,
Yes, ma'am.
I think there's a background noise from your end.
There was no noise. It is not audible, ma'am.
Yeah, the audible, but
actually,
there are some other source.
Yeah, there is some other source of noise.
Give me a second, ma'am.
Some maybe sound coming from background sound coming from maybe Tamil Nadu.
Yes.
Is it audible now, ma'am?
Yeah, now it is clear.
Okay, ma'am. This is the methodology of my literature. First is the collection of literature, the factors which are contributing to labor productivity and sleep cycle, then the preliminary analysis of CRM dynamics, and then the method of data collection, and then data analysis, results in discussion, conclusion, and future scope. These are the different stages of sleep of a thing. That is awake sleep, REM sleep, light sleep, deep sleep, and then power nap is considered a short amount of sleep, which is in the form of light sleep, which makes the body rest and next makes it active for work. It is always a small duration of sleep. Then the data collection. The data collection is done by the mobile application method. That is, there are two types of apps which are like Pillow and Sleepboat apps, which will track the amount of sleep or the different stages. And using that one, it will predict the sleep score. How does the app record the sleep? Is by oxygen wave movement of the breathing of a human being. It is the oxygen saturation as well as the breathing of a person. It should be like 10 meters of 10 meters of between us, within us. Then the data which are collected from skilled workers, unskilled workers, male coolie and female coolie, engineers, project managers, and carpent workers and bar vendors. Then CRM techniques. CRM is defined as a customer relationship management. This is a term which helps in the understanding the relationship between the productivity of the laborers and sleeping patterns, and then the workflow and the business rules are the based of the algorithm. How we develop the algorithm for analyzing. For this CRM technique is used in this one to better the accuracy level of the thing. And the dashboard is which works. It is a tool which helps in the where we are working, where we are generating the equation, where we are generating the formula. That is called as the dashboard. Then Azure services and the data which is Azure services, that is like an iCloud, where the data which will be which will be using will be stored in the thing, and anyone in the past it can be used. It is based on the IoT concept, that is the Internet of Things concept. Then the Bayesian network. In CRM, the algorithm which is used is called as the Bayesian network. It is a probability network which helps in the studying the relationship between the labor labor productivity and sleep deprivation, as shown in the thing here. It helps in predicting anomaly detection, diagnostic, reasoning, and decision making under certainty conditions. That is helps also in artificial intelligence. This works with artificial intelligence in a neural network system. That is, P stands for probability to predict, A is the labor productivity, and B is the sleep deprivation. Using this one, the CRM technique is being used in the dashboard. Then in the results and discussion, Pillow app is the iOS app, and then Sleepboard is the Android app, which will be all these apps will be installed in the labor's mobile, and the data will be collected for one particular month. Along with that, the labor productivity chart also will be collected. Then there will be a comparison you are predicted, and then the data which is collected will be interpreted in the CRM software using artificial intelligence. Then from the results, we will be generating the probability equations. Then after that, using that one, we'll be plotting the graph. This is the daily progress report of the labor. And then this is the application method of the different stages of sleep. How does it vary? And then this is the representation of CRM dashboard. How does the CRM network work? Then the sleep versus productivity. How does the chart vary for effective productivity? Effective productivity, at minimum of 85% of sleep is required, as shown in the graph. This is a general representative. We have done it for n number of labors also. This is my part. And then the final conclusion is that this study will provide valuable insights about the sleep environment and the habits of laborers, which cause the tiredness and operational influence in several other sectors, which mainly affect the poor productivity in the construction site. And then the site engineers and the project manager, who are very less in numbers, should make sure that the laborers are aware about the sleep. How does it have an impact on the health of the laborers, and how sleep is more important in labor. This has been considered. These are the reference. And thank you for listening. This is one of my part of my PhD project. Thank you so much.
Thank you, Satvik. Very nice presentation. Thank you. Okay. Friends, next presenter, Ghazala Anjum and
Yes,
Dennis Kumar. Yes.
Yes, sir, I'm here.
Yes?
Yes, sir. Shall I start?
No. 1 minute. Ghazala Anjum and Dennis Kumar is going to present a paper on the topic of effect of alloy site, nano clay and carbon nanotubes on flexural strength of nano cement paste. Yes, you start. Okay. Ghazala,
Thank you, sir. Yes, sir.
take only 15 minutes.
Yes, sir.
And then present paper.
Yes, sir.
Okay.
Are you able to see the screen, sir?
Yes. Go on. It's visible.
Yes, sir. 1 second. It's visible, sir, properly?
It's visible. Please go on.
Okay. Thank you, sir. So, my name is Ghazala Anjum. I am a research scholar with the Department of Civil Engineering at Gaussiya College of Engineering, Ramnagaram. And I am doing my PhD under the supervision of Dr. Ernest Kumar, who is a professor and a HOD of Department of Civil Engineering, Gaussiya College of Engineering, Ramnagaram, and the research center is also the same. My topic is on effect of halloysite nanoclay and carbon nanotubes on flexural strength of nano cement paste. And I humbly thank the organizing committee of SNPCE for providing me an opportunity to present my work in the international conference. So the objectives of my work is to study the changes in flexural strength in control specimens, that is the normal cement specimens and nanocomposite specimens. That means cement mixed with nanomaterials, and to evaluate the stress-strain relationship of different percentages of nanomaterials that are added. And thirdly, to study the morphology, to study the elemental composition and the phases of fractured specimens using SEM, scanning electron microscopy, EDS or EDX, energy dispersive X-ray spectroscopy, and XRD, X-ray diffraction. So when we go into the term nano, it means 10 to the power of minus 9 meters. Materials as small as 10 to the power of minus 9 meters. Because there is a considerable increase in size to volume ratio, they have a prominent effect on the material performance. Since they have a very small size, their ability to mix in the cement admixture is great, and hence the performance increase provided by these particles is also great, even if they are added in very less quantities. So this will help in developing new hybrid mixtures which provide greater strength to concrete along all its properties: greater flexural strength, greater ductility, durability, toughness, etc., with minimum quantity. So currently the various nanomaterials that are being used are nanosilica, nano titanium dioxide, nano fly ash, and nano lime. These are the most prominent ones. The current ones that I have adopted, that is carbon nanotubes and halloysite nanoclay, are the recent inclusion into the list. Okay, so for the thing about the major drawback of CNTs and titanium dioxide and fly ash is that they are very costly. Their synthesis requires a lot of procedure, a lot of carefulness, and they are very costly. And whereas HNC and other nanosilica are easily synthesizable from the materials that are available in the earth crust. So their variation in properties and their ability to enhance the cement performance is what I have studied. So the pros and cons for the nanomaterials are, they are great. Nanomaterials are great for resisting the cracks. They provide durability, long service life, small, lightweight. They are also temperature independent, which means they don't burn. They tolerate higher temperatures as well as lower of temperatures easily. They have a high aspect ratio. And HNC, as I said, being a nano clay criteria, even though it is in nano, even though it falls in the nano category, it still has low production cost. Whereas the cons of the nanomaterials are a little understanding about the workings of nanomaterials. That means we know what they do. The researchers and the people who have conducted experiments, they know what they do, but they cannot exactly pinpoint why they act that way or why they do what they do. That is, most on a molecular level, we have no understanding of how they work. And we cannot work with individual tubes since they are very small. We have to work with clusters only. It is not possible to work with individual tubes. And as I said, CNT has a very high production cost, and because of their cost and because of their production, we have not seen any large scale implementation so far. So here is the materials that I used for for my project. So cement, normal OPC 53 grade cement, and sand that was locally available and passing through 1.8 mm sieve. Water, the ordinary water from college laboratory, and the carbon nanotubes we procured from Nopo Private Limited, Jigani Industrial Area, Bangalore, and halloysite nanoclay we procured from Sigma Aldrich, New Zealand. As you can see, the carbon nanotubes are black in color, whereas the halloysite nanoclay is white. So, and this is the equipment we have used for. This is a multi-test 25i nano universal testing machine, which is present in which we procured and is established in the R&D Center of Vasya College of Engineering. The equipment was funded by Vision Group of Science and Technology, Bangalore, under their KFS Level 2 program. It has 1 kilonewton to 25 kilonewton loading capacity with different load cells. It comes with automatic data acquisition system. It has an inbuilt software called Emperor, which calculates the required results and graphs for us. And the handling or the changing of load cells or the mechanical handling is quite easy, and it provides it provides a high control on the experimental procedure. So this is the experimental methodology. I determined 3 mechanical properties: flexural strength, stress strain relationship, and stiffness of the specimens, and studied the microstructure properties, SEM analysis, EDX, and XRD. So the methodology is the specimens of 40 into 20 into 100 mm were prepared, and a percentage of nanomaterial, both CNT and HNC, by different percentages, 4, 6, 8, and 10% by weight of cement was added into the specimens. At water cement ratio of 0.45. The molds were styrofoam board cutouts. This is because since the specimen size is very small, the standard cutouts are not available easily. So instead of normal plastic or metal molds, I use styrofoam board cutouts. Cement and sand is mixed in the ratio 1:2. So the procedure is fairly simple. I did the mixing first using this is non-uniform dispersion using a simple kitchen sieve. I try to distribute the nano material substance as uniformly as possible in the dry mix, and then I added some water, sprinkled some water to ensure cement adheres to the nanotubes and not the other way around, because CNTs are hydrophobic. They do not they repel water. After that, from in the cutouts, I filled the sample and made the mold. And after 24 hours, the mold was removed and put for curing. And this is how the testing was done. The sample was mounted on the 3-point bending apparatus in the machine. And once the testing was started, the load was applied at 0.5 mm per second rate. So as you can see, the load application starts only when the top object touches the bottom, this one. It does not come and impact the specimen. It starts gradually from zero itself. And as you can see, there is cracking for this. The major point in this study is that the specimens are not loaded to failure. They are only loaded until cracking, which amounts to 20% of breakage of the specimen. Why we did this is because the equipment currently has the capacity, the equipment that is being used here has the capacity of only 10 kilonewton. Okay, anything more than that and the machine overloads. So by trial and error, we established a 20% breakage of the specimen is enough for the cracks to form or the material to start breaking or start the failure process. Hence, all the loads and all the data that is available, they are based on first cracking loads and not on the complete failure. So here are the results. As you can see, the frictional stress at 3, 7, 14 and 28-day testings. As you can see in all the graphs, the one second. In all the graphs, the cement, even though there is a constant increase of cement strength from 3 to 28 days, it is still less than the cement nanomaterial composite. Okay, and what we observe here is the strength gain of HNC at 3-day to 7-day to 14-day to 28-day is quite rapid. Even at 3-day, there is considerable strength. Whereas in case of CNTs, the strength gain is low. At 3 days, it is still less than HNC, and at 7 days also, it is still less than HNC, even on 14-day. But on 28-day, you see some percentages of HNC is almost as high as CNT here. So the strength gain using in HNC compounds is fast and higher, whereas in case of CNT, it is higher, but it is slower. Similarly, the stiffness also, as you can see, there are certain, as the loads increase, I mean, HNC has lower stiffnesses and CNT has higher stiffness. Maybe this is the reason, because the strength gain is less, because since the stiffness is more, the strength gain is slow. But slowly the stiffness here reduces, stiffness here reduces and then the strength increases, whereas in case of HNC, the stiffness is initially smaller and then it increases, the vice versa of the CNT. So the strength gain is faster and higher in case of CNT rather than HNC. HNC rather than CNT. And these are the results for the stress strain graphs that we have obtained. As you can see, for cement mortar, for all the days, the stress strain graph is gradually increasing. And even for different percentages here, there are 4, 6, 8 and 10 percentages graphs even here. As you can see, the growth is more or less similar, except for this 1, 6%, which is deviating from the other lines. And even in case of here, the growth or the graph is more or less same for all percentages, only it is changing for 8%. This change is attributed to human error either during loading or mixing or some calculations. So next is scanning electron microscopy, SEM. We got the samples from we got the results from Center of Incubation, Innovation, Research and Consultancy from Jyoti Institute of Technology. These 4 pictures are the CNT images sample, and these 4 are the HNC sample. If you observe, there is different there is different zoom values. It is zoomed at different magnification, and here if you see, you can see fiber like structures here. I hope you can see there are fiber like structures here in cluster forms. These are CNTs, and if you go further, you can see how the surface is jagged, and there are I don't know which area they have increased here, they have not marked. So I think there is one here, there is a few here and a few here, clusters of CNT. Whereas in case of HNC, it's completely incorporated. There is, even after magnifying on the crack, the distinction between the cement matrix and HNC is not clearly visible, and this is visible because of basically hydrophobic property of the CNT, which will keep it away from water molecules. Whereas this, my only assumption is that HNCs are probably mixing with the water, because of which the matrix is dense and thick, and hence there is no proper differentiation between the compounds. Coming to the EDX analysis, which tells us the composition of the sample, as you can see, the difference between CNT and HNC is, there is this CA is actually known as wollastonite. It's an impure form of limestone that is used in cement. And here there is a difference between silicon present, because HNC is basically an aluminium silicate compound. So silicon content in silicon and aluminium content in HNC is more as compared to CNT. And X-ray diffraction, we have got peaks. These high peaks are because this is CNT XRD, and because it has a better crystalline structure than nanoclay. And the results came a few days ago. So studying XRD is these graphs I still have to do. And so coming to the conclusions, what we have seen is to achieve the first crack, the load required or the stress required to achieve the first crack, it increases from 3 to 28 days. And hence the stress also increases. What we found is at the 28-day testing, 10% weight of CM and CNT samples and CM and HNC samples showed nearly 193% increase in strength, CM CNT samples, and 22.45% strength gain in HNC sample as compared to normal cement samples. And highest stiffness was also observed in highest stiffness was also observed in similar specimens. And as I said, the CNT stress curve is same for all percentages except for 1, which is 6, and CM and HNC is also same for all percentages except for 8. And SEM shows fiber pullout as well as stretched fibers, which I explained. Fiber pullout it's not exactly clearly visible, but you can see the smaller holes, the very, very small holes that are visible. Those are indications of fiber pullout, where the fibers have disembarkated from the matrix. So that, and there are some fibers that are particles that appear stretched here. So that is available, and so far that is what the study has concluded. There are still a lot to be done, that is for my PhD, but I have presented a part of what I have done recently. So I humbly thank the Vision Group of Technology for funding our project. And these are the references that I have used regarding the experiment, and thank you. That's all.
Thank you, Gajala Anjum. Very nice presentation. Now there is a presentation over. Then I'll request to any questions from participants? Any questions from listeners? Hello? Hello? Any questions? No questions? Hello, any one question? Hello?
Sir, there is no question in the chat box. So I think no questions
Okay.
from the audience end.
Okay, there is no question.
Sir, one minute.
Yes.
Vidya.
Yeah, Vidya.
What are the parameters effect on strength of? Yeah, sir. Sir,
Sorry?
questions for first topic.
Yeah,
Effects
your
of quality
question is,
stands.
yeah, first question is go for the, yeah, Saeed Praz Siddiqui.
Yes, sir.
Yeah,
Can you
first
please repeat the
presenter,
question?
effect of water quality and strength of concrete is given by author. So one question from audience or participants.
Yes, madam. Vidya madam, can you please, Vidya ma'am, can you please repeat the question?
Sir, what are the parameters in water affect the strength of concrete properties?
Ma'am, parameters have been listed because we have taken pH value, we have taken BOD, we have taken acidity, we have alkalinity, we have taken, and yes, dissolved oxygen, total hardness, and all these parameters have been considered before. Yes, before we have done it. These are the parameters what we have considered, ma'am.
Okay, sir. But what parameters is more effect on the strength of concrete, sir?
Any she is asking any significant of any parameter. Any significant of any parameter.
Yes, sir. One minute. This graph. One second. I'll just show it in the graph. 1 minute, sir.
Okay.
This one.
No, tell me. No, nothing. Don't need. Okay. Go ahead. Okay.
Sir, actually what is happening here is with respect to Chikbanawara Lake, the pH value is 8.8. It is very much acidic. Sorry, basic. It is very much basic. Okay. So that might be the reason behind my compressive strength as well as the split tensile strength, because when I'm seeing the parameters with respect to Chikbanawara Lake, it is either pH value or it is total hardness, and the chloride content also is little bit high in case of Chikbanawara Lake. So that might be the major factor contributing to my compressive strength, in reduction of my compressive strength, madam.
That is one is other reason is maybe sulfate attack or chloride attack. If
yes, sir.
Water is maybe contain some high impurities
yes,
in
sir,
form of TDS. It may be effect on the strength of the concrete. But
yes,
in your study, always use potable water. Potable water means safe water or drinking water. That is potable water for use for the drinking. Don't call it as potable water maybe in your research.
Yes, sir.
Potable water means treated water. There is a costly water that is always utilized for the drinking purpose only.
Okay, sir.
Or as conventional water or raw water.
Okay, sir.
And another word is introduced in your research.
Yes, sir.
Sewage water. Sewage is the waste water.
Okay, sir.
Sewage water, no, there is not a sewage water.
Yes, sir.
Nowadays, they are not called as sewage water.
It is
waste water. Either maybe domestic wastewater or municipal wastewater.
Yes, yes.
Including any industry waste, treated wastewater, that is called as municipal wastewater.
Yes, sir. We'll do the changes, sir. Thank you so much.
Yeah. Thank you.
Thank
you, sir.
Thank you, Vidya ma'am. Thank you, Vidya ma'am, for the question. Thank you so much.
Any questions from any others? No questions. And second author given presentation on plastic, waste plastic as a replacement for coarse aggregate in concrete. Okay, Mr. Shashank. Hello.
Yes, sir.
Shashank, is a plastic have any binding capacity?
Yes, sir. As what the literature says is, until up to 25%, it gives strength on par with the conventional concrete, sir.
Okay.
So whereas if the plastic quantity in the concrete increases, the strength is decreasing, and that is mainly because of low interfacial transition zone, sir, which basically means the bonding between the plastic and concrete is less, because the surface of the plastic is very smooth, sir. So as of that, there is not that much of binding between the plastic aggregates and the concrete. Whereas by addition of mineral admixtures, it has again showed an increase of around 3 to 4%, which means the pozzolanic activity of the mineral admixtures is quite helpful in the bonding of plastic.
Okay, okay. What about during melting of plastic?
Yes, sir. The plastic.
Yeah, that is any effect on the our atmosphere or surrounding area during conducting?
No, sir. No, sir. Because plastic, when melted around 150 to 160 degrees, it does not have. It does not exhume any harmful gases.
Some gases, no gases.
Yes, sir. That is what, sir. That is the advantage of mechanical process, because in the extruding process.
Okay, okay.
Yes.
Next, Satvik. Hello, Satvik.
Yes, sir.
Sir, there is one more question for Mr. Shashank. Abhijit here.
Yes, sir.
Dr. Abhijit asking some questions.
Yeah, I mean, regarding waste plastic being replaced as coarse aggregate. Okay.
Yes, sir.
So, what would be the specific gravity of plastic?
Sir, plastic specific gravity for HDP it is 1.04. Whereas for PP and other plastics, it is around 0.9, which is below the specific gravity of water, sir. It actually floats in water.
Yes. So when that is the condition,
yes,
what
sir.
would become the workability of the fresh concrete? Because the other materials in the concrete like cement, coarse aggregate and fine aggregate will have a specific gravity greater than 2.
Right, sir.
Specific gravity of cement is 3. Specific gravity of coarse aggregate is around 2.6 to 2.7.
Right, sir.
Isn't it? So when that is the case, if you are trying to mix a lighter material, I mean, that too, if you say if it is less than 1 which floats in water, so then mixing itself will be a very tedious or a difficult process. It doesn't get integrated into the concrete.
Right, sir. Right, sir. Yes, sir.
So
So that is one of the main reasons why 100% is not able. No, it's 100% replacement is not possible, sir. Because if we add 100% of it, it starts floating when the concrete is allowed to set.
Yeah, even if it is a lesser percentage, even if it is in a lesser percentage, the moment the vibrator, the compaction process is adapted, these light materials will come onto the surface.
Yes, sir. That is what the process of compaction has to be done carefully, and because if it is with the help of a vibrator, again it is very common. It will come and float on the surface, sir.
Yeah, I mean that segregation will be there.
Yes, sir. So that is what, and moreover, we have to reduce the water content because this slump will be increasing, sir, when we add the plastic aggregates. So because of which, if we work on the water cement ratio and by adding mineral admixtures, so basically we can control it, sir. Actually, while casting also, we had this problem, and again, to resolve this problem, we had to compact the concrete without much of disturbance.
Okay.
Okay.
I mean, have you experimentally conducted some cube tests?
Yes, sir. Actually, this paper is a literature review, sir. But for my MTech thesis, I had actually casted the cube, sir.
Okay. If that is the case, how did you determine the specific gravity of the plastic if it is less than 1?
Yes, sir. We had to actually do it by instead of water, sir. We had to put it in a kerosene. So because of which, that is how we could actually do it. Oh, 1 second, sir. If possible, I'll show you the.
No. That is perfect. Whatever you have done is correct.
Yes, sir.
Yeah,
it was not possible with water, sir.
Kerosene is around 7 to 8. You can 0.7 to 0.8.
Yes, sir.
And this plastic will definitely get immersed in it, so you could determine the.
Yes, sir. Because in the metal case basket, when we put it in water, the plastic started to come up, sir.
Yes.
So that is what we did. Yes, sir.
Yeah.
Okay.
Thank you.
Thank you, Dr. Abhijit. Thank you. Then I will request Dr. Durga Prasad.
Yes, sir.
Please conclude these sessions.
Yes, thank you very much, sir. So overall, the presentation of all the research activities were quite interesting, and the presentation was quite clear in what exactly they were looking out for. And so to conclude with whatever the paper presentation were as of today. So I would like to just have a discussion with a couple of research papers presented. Coming to paper number 1, that is the effect of different water. Hello? Hello?
Yes, sir. You're clear.
Yes. Coming to the first paper. So in this case, see, the code clearly says that you have to use potable water. Uh, in spite of this, what was the actual reason behind trying out different sources of water?
Yes,
Hello?
sir. Sir, basically here potable, because we have few areas where we do not have access to potable waters. So getting water there for the concrete becomes very difficult. So at that particular point of time, the water source, whichever we have nearby, would be more feasible for us to use. So that was the uh, basic thing which we had in our mind, and we were looking forward for that, sir.
Okay, thank you. See, as again, Sir told just 5 minutes before
Yes,
that
sir.
instead of potable water, as I said, the conventional water
We'll
what
do
you
it, sir.
use
We'll
should
do
be
it, sir.
better.
Yes,
And
sir.
also, just because you do not have access to conventional water, you cannot use whatever water is available, and you cannot just try it. You have to ensure that, see, in what way you can get that available water to a property related to that conventional water. That would be better. And also, see, with your work presented, I just got to know that you have only conducted the strength properties, that is the compressive strength or the other kind of strengths. So see, it does not mean to say a better strength has always resulted in better performance. So I would suggest that beyond the strength properties, you can also try for the performance and durability aspects of this particular uh, usage of water in different concrete activities.
Yes, sir. We have noted down your comments, sir. We'll definitely do that, sir.
Yes, you can just proceed further for
Yes,
better
yes.
understanding.
Great, sir. Great.
Okay,
Thank you so much.
because better strength does not
Yes.
guarantee the better performance.
True, sir.
Okay,
True. Yes, sir.
so this is with the first paper, and coming to the second paper, see, with the references or the reference part, I just got to know that the literature from where you have referred, probably the quality of literature review can be much better. And also the presentation had more of the information related to what type of plastic, how plastics are produced or something. But once you're concentrating particularly on plastic aggregates, so it's much better to focus on the aggregates effect on the regular or conventional concrete. So this is what my observation was,
Okay.
rather than giving into the manufacturing, how much it is produced. So it's almost half or 60% of the presentation were into what kind of plastic, everything. So once you're directly jumping into this plastic aggregates, so we just want to talk more on how feasible the aggregates are rather than the source or whatever it is. So, and coming to the other paper, that is the effect of nanotubes. So see, whatever we do today, it's very clear that it should be economical. The whatever the in terms of material or handling or anything, the overall cost should be economical and feasible as well. So
Yes, sir.
since the nanomaterials are again costlier, and the handling of that material, I don't know whether it's easy or does it require a skilled person to handle it. So how do you justify the economy in this case?
Sir, currently, if we talk about the current situation, the carbon nanotubes, as I said, they are currently costly.
Yeah.
But the thing is, the raw materials available to manufacture CNTs is available in plenty. Basically, any substance that has sufficient carbon amount can be used for the manufacture of CNTs. So yes, today it is costly, but it may not be so tomorrow. So in that sense, maybe in future, it might be helpful for the use of nanotubes, because nanotubes is the products that are basically taking over every industry, from automobiles to pharmacies.
What about durability?
Durability, the study has not yet been done, sir. My
That is
study
very important, because
Yes,
in
sir.
different atmosphere, different climate condition, you'll maybe lose the some
Yes, sir. I
physical
know.
observation also. No, physical observation also very important.
Yes, sir. That's
Because
what it
this
is.
is a decoration materials. No, this is a very
Yes.
That's
That's what I
appearance.
said, sir. You know, there is no large scale.
Yeah, you tell that. Yes, you draw the some conclusion also with respect to durability, with respect to appearance. That is
Yes,
also one of the study. No problem.
Yes.
No problem. Nothing. Don't worry. That is not.
Yes, sir. Yes.
Yeah, you draw the some disadvantage also.
Yes,
Okay.
sir.
Go ahead.
Okay, so see, considering concrete to be concrete by itself to be a costlier material, so addition of nanomaterial would be much costlier. That is what I meant to say.
Yes,
Okay.
sir. Actually, my study is not on concrete, just concrete. Sorry, not concrete. Cement mortar. I mean, cement plus very fine sand. 1.8 mm passing sand is very fine, almost fine sand. So
Okay,
it's on mortar currently.
Okay, it's currently on mortar. Finally, it should just get into concrete.
Yes.
Is it?
Yes, sir. It's a recent study. It's a recent inclusion. So the progress is quite in the
Okay,
beginning
you can
stage.
just let you know that economy is also very
sir.
important. Okay.
Yes, sir.
Okay.
So
Okay,
I
nice,
think I'm done with my observations, sir.
Okay, nice. Thank
My
you.
paper.
Yeah, your paper, Satvik.
Yes, sir.
Yeah, you was not consider social aspect during data collection.
So social aspect we have not considered. So only about regarding the labor perspective only we have collected, because the labor health, their psychological behavior, their background study, and then their safety. All these aspects were considered. Only these.
Yeah, that is, if any consider social aspect, that is also good criteria. That is also one of the factors affecting on your study.
Okay, sure.
Okay, very nice. All are given a nice presentation. Thank you for all authors. Good luck for your research work. Thank you. Then our mic hand over to Professor Ranjita.
Yes, thank you, sir. I thank the chairpersons of the session 3, Dr. Durga Prashant L. and Dr. G.P. Shivshankar, for their informative inputs. I also thank all the speakers for the wonderful presentations. Thank you again. With immense pleasure, thank you, sir. With immense pleasure, I would like to introduce today's keynote speaker, Dr. Vivian Robert. Dr. Vivian Robert is a chartered engineer with background in traffic and road safety engineering, currently focusing on transport policy and strategy. He has over 20 years of experience in various areas of traffic and road safety engineering and has worked across geographies in Asia, Middle East, and Western Europe. He has completed Doctor of Philosophy in Road Safety Engineering in the year 2006. He is a fellow at Chartered Institution of Highways and Transportation UK. He is a chartered member, Institute of Engineers India. He is a member of Indian Roads Congress, India. He has worked in various capacities, including Senior Traffic Engineer at Scott Wilson, India during February 2006 to January 2007, Traffic and Road Safety Team Leader at Atkins, UAE and India during January 2007 to September 2010, Traffic and Road Safety Specialist at Public Works Authority, Qatar from September 2010 to June 2016. He is a strategic consultant at AECOM, Nottingham, United Kingdom from June 2016 till date. He was visiting faculty at BMS College of Engineering during 2003-2006. He was also visiting faculty at Rasta for PG Diploma in Highway Engineering from 2003 to 2006. He has given guest lectures at Bangalore University, Dayanand Sagar College of Engineering, and MANIT Bhopal. He has been invited as a delegate and keynote addressee at a number of conferences and seminars. He has over 15 research papers published in Indian and international publications. Sir, it is our privilege and we are happy to have you with us today, and I wholeheartedly welcome you to present the keynote address. Sir?
Thank you very much. Thank you very much, Professor Ranjita, for the wonderful introduction. Good afternoon, everyone, and thank you to the organizers of the conference for inviting me to deliver this keynote presentation. It's an absolute pleasure for me. It's almost 12, 13 years since I'm back at Dayanand Sagar College, although virtually, so it's a good feeling now. I was having a look at some of the interesting technical presentations in the session so far, and well done to all the presenters. The presentations were really good. But the one thing that I noticed, they were mainly based on concrete construction, etc. So I hope there is enough interest still in the audience, because this topic that I'm going to present on road safety is completely different to concrete. So the presentation is approximately, say, 50 to 60 minutes long. But in the next 60 minutes or so, what might happen in India is about 16 to 18 people will be killed on our roads. This is absolutely unacceptable, and it's an extreme loss of life, and which can be eminently preventable. This imposes a huge burden on society and loss of valuable lives. So the topic of my presentation is how to successfully implement a road safety strategy by using the safe systems approach. Just to give you a little bit of a background on the global situation. The world population as of now is about 7.6 billion, and it increases year on year by about 83 million. And motorization increases at about 4% every year. This is the global average, although it is rising at a much more rapid rate in rapidly developing countries like India. The road traffic deaths are approximately around 1.3 million every year. And it's been around the 1.25 to 1.35 million deaths per annum since 2007. The current figure is the one that is published by the World Health Organization for 2018. Now, because of COVID, I think a lot of us are more familiar with the term pandemic. World Health Organization defines a pandemic as an epidemic that occurs worldwide or over a very wide area, crossing international boundaries and usually affecting a large number of people. Now, try to put this in the perspective of road safety. Road traffic collisions occur worldwide. It occurs across international boundaries and causes a lot of pain and grief to families and societies. Yet, we do not really give it the importance it deserves. Again, if you also go back and compare the numbers affected by road traffic collisions every year and the current pandemic that we are dealing with, there are startling similarities in the numbers as well. I'll let you come up with your own analysis and comparisons. That is not the topic for the current presentation today. However, I'm not sure about you, that the same amount of thought, research, and investment is actually being channeled towards the cause of reducing global trauma due to traffic collisions. As a conservative estimate, at the current rate at which road traffic fatalities are happening, over 265 million people will either be killed or seriously injured over the next 15 years due to road traffic collisions. Just to put things in perspective, the top 3 countries in the world by population are China, India, and the United States. And the number of people that will be killed or seriously injured in road traffic collisions will be more than the population of the 4th most populous country in the world. Now, these are startling numbers, and I think we need to sit up and start taking notice of these. In India itself, every year, there are over 5 lakh collisions, resulting in about 1.5 lakh people killed every year. This is the leading cause of death in young people in the age group of 18 to 45 years, as almost 70% of those killed are within this age bracket. As we all know, India is a young and growing country, and this is a serious loss of human capital, not to talk about the grief and trauma suffered by society and families. Looking at the distribution of deaths by road user category, Over 35% of the deaths are two-wheeler drivers, and another 20% are pedestrians, cyclists, and transit passengers, which means that almost half the deaths are vulnerable road users. Human bodies are fragile and can only resist a certain level of crash forces. The level of resistance depends on a number of factors, but the point is we should not consider ourselves invincible. We are not. But still, a lot of us don't behave responsibly on the roads. Let's just say, for argument's sake, we all know Usain Bolt, isn't it? So he is, at the moment, he's the fastest human. So the winner of the 100 meters Olympic sprints. And at the rate at which he runs, he approximately runs at about 30 kilometers an hour. And just imagine if we were to go and sort of throw ourselves in front of him as he's speeding towards the finish line. There is no chance in the world that we will be unhurt because of the collision. But at the end of the day, he is a human being, probably weighing about 100 kilos. But today's motor vehicles are a lot more powerful, a lot faster, and a lot stronger as well. So there is no way that we can come out unhurt if we are hit by a moving vehicle. In terms of trends reported in road traffic deaths, the fatality rate is about 11 to 12 deaths per 1 lakh population. And this is sort of flattening over the last 3 or 4 years, but definitely not reducing. And I think what we need at the moment is to see that the rate is reducing. The government is putting in a lot of measures and trying to bring in a number of initiatives. However, as mentioned previously, there needs to be a proper coordinated effort in order to reduce road traffic collisions. Now, I know we have a very learned audience, but do we all know what India's road safety vision for 2020 is? The vision is to make transport on roads efficient, safe, and sustainable, and to reduce the fatalities on roads by half compared to our 2010 road deaths. Almost 5 years ago, during the second global high-level conference on road safety held in Brasilia, India committed to reduce the road traffic deaths by about 50%. And it was pledged to achieve this by 2020. And we've got another 22 days to go for the end of 2020. Now, what is the challenge that faces us? In my opinion, our vision itself is our greatest challenge. We know the current reality of the situation, but this is not a platform to debate the philosophy and thinking behind committing to the vision. In fact, this should be a forum where we can get a collective thought on what can be done. From a personal perspective, I would say that despite the fact that the pledge was done with all the best intentions, it was perhaps done without an appreciation of the magnitude of the challenge and the ground realities. Even the best performing road safety jurisdictions in the world have achieved this success by constantly setting and reviewing targets. And in many cases, it has taken decades to see the magnitude of reduction that we pledged to achieve in 5 years. Further down the presentation, I will propose some topics for thought on how the vision can be developed and how targets and objectives can be adopted. At this point, it would be fair to say that we are nowhere close to achieving our vision. Based on the vision, we should have been approximately at about 75 to 80,000 deaths right now. However, we are still at over 1.5 lakh deaths. I can't emphasize this enough, but road safety is a joint responsibility. It's not just for central and state governments, but also a partnership between the government, the public, the various NGOs, etc. And more importantly, for us as users of public places. For a number of years, road traffic crashes have been acknowledged by the United Nations and member states to be a considerable challenge to the achievement of health and development goals. During the past decade, this issue has gained a lot more prominence, and it has been sort of understood as one of the world's more pressing international health and development concerns. The decade of road safety was proclaimed in March 2010, and 2011 to 2020 was officially proclaimed by the United Nations as the Decade for Action in Road Safety. Without any action, it would have been possible that there would have been 1.9 million deaths by 2020. And the Decade of Action was proclaimed with the target to save about 5 million lives by 2020. We also know that the progress towards this target has not been achieved, and the UN recognizes that. And also please note that the target reduction of 50% was over a period of 10 years, which in itself was a major commitment, but not over a period of five years as pledged by India and Brasilia. So what it also goes on to acknowledge is that road-related goals can only be achieved through stronger national leadership, global cooperation, and through implementation of evidence-based strategies. So now, considering the point that the targets that were set for the past decade from 2011 to 2020 were not made, the United Nations has further adopted a new resolution on global road safety and will call 2021 to 2030 as a new decade for action in road safety. Again, the resolution reiterates the invitation to the international community to intensify national, regional, and international cooperation with a view to meeting the ambitious road safety related targets for 2030. Now, before we go on to actually what safe systems mean and how we can use safe systems as a potential approach in which to frame our road safety strategy, I'll quickly talk about the evolutions of road safety management systems over the past 50, 60 years. There have been progressive shifts in road safety management thinking and practices. In the 1950s and 60s, the focus was mainly on driver interventions, possibly just education, I think. In phase two, which was around the 70s and 80s, the focus was more on education and enforcement, with a little bit of engineering being introduced. Phase three, which is still quite popular in countries like India, is when the focus on 3 E's was developed, which was engineering, education, as well as enforcement. And we're currently in phase 4, which is the focus on system-wide interventions and long-term elimination of deaths and serious injuries, and a shared responsibility. This is what we call as a safe systems approach. And the new pledge by the United Nations is 50 by 30, which basically means halving the number of road deaths and serious injuries by 2030. So what is a safe systems approach? The safe system approach represents an ambitious safety performance level. And this has evolved over many years and derives most notably from the Swedish Vision Zero and the Dutch sustainable safety strategies. So the safe system is based on a number of underlying principles. And the most important one is human beings make frequent mistakes. And these mistakes lead to road traffic collisions. The human body by nature has a limited ability to sustain collision forces. And therefore, it's a shared responsibility between all the various stakeholders to take appropriate actions to ensure that the collisions do not lead to serious or fatal injuries. Now, let's take a particular scenario. When a vehicle is traveling on a rural road at very high speeds, loses control on a bend and overturns, the crash is likely to result in a road death or in a serious injury. But under a safe system, driver and any vehicle occupants should have a much lower risk of death or suffering serious injury because the vehicles themselves will be fitted with advanced safety features, including electronic stability control, front and side airbags, head restraints, etc. The road surfaces will be much improved and roadside objects will be either removed or barriers installed. Speed should be managed by appropriate speed limits, self-explaining roads that encourage safe speeds, as well as devices like intelligent speed adaptation. And finally, road users themselves are alert, they obey the rules of the road, and are aware of the risks associated with using the road. So the focus for the safe systems approach is on people, not on crashes. And the focus again is on severity, not on probability. So this represents a paradigm shift in focus to addressing road safety issues. Now, before we apply the safe systems approach to develop a road safety strategy, we need to ensure that a proper road safety management framework is in place. The framework must be developed on the basis of an effective practice, and we can learn this through well-performing road safety jurisdictions. As the saying goes, we do not live long enough to make all the mistakes ourselves. So it would be useful to learn lessons from the experiences of others that have trialed and established systems. At a minimum, the framework should identify those elements of management that are crucial to improving the road safety performance. So we can sort of view the road safety management framework as a pyramid with at least 3 levels. The levels can be reviewed, added, or removed on the basis of experience. However, for a country like India, it would be useful to start off with the 3 levels. Institutional management functions, which lay the requirements for the development of interventions. Interventions, which in turn produce the desired results. The results need close monitoring at the micro and macro levels so that the stated targets and objectives are achieved. One way of doing this is by setting interim KPIs and PIs. So as we all know, for any management framework to be effective, we need to have a strong foundation. And the foundation for the road safety management framework is strong institutional management functions. These functions are mainly delivered by government agencies with core road safety responsibilities. So for example, in our case, it could be the Ministry of Road Transport and Highways. It could be the planning departments, the justice departments, police, health, occupational safety, etc. So what these functions will represent is the desire to achieve better road safety results through a performance review and through analysis of the scope for improvement and through setting long-term goals and ambitions. In the absence of a clear and accountable focus on results, all other institutional management functions and interventions will lack cohesion and direction, and the efficiency and effectiveness of safety initiatives can be undermined. As we've learned from several international best practice examples, government partnerships with civil society and businesses in alignment with the country and organization goals and targets can bring about better results, coordination, and buy-in. I would understand that most of the audience here are from the professional and research community. And I think we are the ones that will provide key support for demonstrably effective next steps. And finally, the results focus also should be an effective, overarching institutional management function. So for India, what can a road safety framework look like? As many of you might be aware, way back in 2007, the Sundar Committee report on road safety and traffic management recommended a national level governing board that will coordinate all activities related to the reduction in road traffic collisions in India. The good news is we now have a National Road Safety Council. The council was established in 2015, and it's also backed by a strong national road safety policy, which has been approved by the Government of India. The policy recognizes that road safety is a holistic issue and will involve roads, motor vehicles, as well as human beings. And the policy statements closely follow the principles of the safe system approach through a multi-pronged strategy based on 4 E's, which is education, engineering, enforcement, and emergency care. So the National Road Safety Council will be the apex body, which will undertake and be responsible for all policy decisions in matters related to road safety. the states and union territories are encouraged to set up state-level road safety councils and hold meetings regularly. It is heartening to note that a number of initiatives are already underway since the National Road Safety Council was established, with priority being accorded to rectification of black spots, making road safety audits mandatory on national highways, reviewing the thresholds for 4-lane national highway capacities, as well as to look at the design and construction of road facilities that will take care of the needs of non-motorized transport and vulnerable road users. The second element of the road safety management function is system-wide intervention. Now, as I said before, this is where most of us will be involved and can provide an effective input. Effective intervention will focus on implementation of evidence-based approaches and will focus on reduced exposure to risk due to death and serious injury. And it will also focus on mitigating the severity of injury when a crash occurs and reduce the consequences of injury. A large majority of us will fit within this layer of the pyramid, and we will respond to the institutional functions by providing key assistance through research, advisory, consulting, construction, or ongoing maintenance expertise. It goes without saying that implementation of effective and proven interventions that are used responsibility is not possible for, without this, it's not possible for institutional functions to demonstrate positive results. So what are we looking at in terms of system-wide interventions? We could look at something related to safety-conscious planning. We could look at proactive safety and engineering design. We could look at encouraging the use of safer modes and safer routes. I think we've heard quite often that as long as we plan for cars and traffic, we will end up getting more cars and more traffic. Therefore, we need to shift our focus, take a step back, probably rethink our planning, and see if we need to plan for people and places, because this is when we will get more livable places for people that is safer for all modes. We should look at safe separation or safe integration of mixed road use and ensure equitable allocation of road space for vehicles and non-motorized users. We can look at managing speeds to crash protection levels. As I mentioned previously, at a speed of 30 kilometers an hour, an able person struck by a moving object is about 90% likely to recover. But as the speed increases, the chance of injury increases exponentially. So this needs to be considered as well while designing our public places. We should consider crash protective roadsides and vehicles. And we should also look at compliant behavior, which deters dangerous behavior, ensuring compliance with key safety rules. We should also look at managing risk through proper vehicle standards, designs, driver licensing standards, etc. And we should also look at fast and efficient emergency medical help, diagnosis, and care. I'm not going to go very deep into this particular aspect in terms of interventions, because this is a separate topic in itself. And also, I'm sure that as a knowledgeable audience, a lot of you have an excellent understanding of these issues already, as engineering safety in road design has been a subject of much interest for close to 20 years now. The only thing I would like to say is the interventions should be evidence-based, and we should look at shifting our focus from crashes to injury prevention. The final element of the road safety management system is the measurement of results and their expression as targets in terms of final outcomes, intermediate outcomes, and outputs. Targets define the desired safety performance and is endorsed by government at all levels and also by stakeholders and community. The level of safety is ultimately determined by the quality of interventions that have been implemented, which are in turn determined by the quality of the country's delivery of institutional management functions. Our final outcomes can be expressed as long-term goals for future safety of road traffic system. For example, as safe system, vision zero, sustainable safety, etc. Whereas interim and short to medium term goals can be expressed in terms of social costs, fatality reduction, serious injury reduction, etc. in absolute terms. Intermediate outcomes are linked to improvements in the final outcomes, and our typical measures include average traffic speeds, proportion of drunk drivers in fatal and serious injury crashes, usage of seat belts, helmets, and the physical condition of safety rating of the road network itself. Outputs, on the other hand, represent physical deliverables that underpin improvements in intermediate and final outcomes. Examples could be kilometers of safety engineering improvements that have been implemented, or, for example, the number of police enforcement operations that have been required to reduce average traffic speeds, increase seatbelt usage, or reduce drink driving, etc. These can correspond to milestones showing that a specific task can be completed. At the end of the day, the countries that have been active are increasingly setting SMART goals for managing their road safety outcomes. It needs to be specific, measurable final outcomes, and have interim outcome targets as well. As mentioned previously, in many countries where the awareness related to road safety is still developing, the capacity to implement national level targeted plans can be a huge challenge to overcome. So in such cases, it might be a better option to adopt the long-term safe system goal, but not to be too restricted or challenged by shorter-term quantitative targets at corridor and project levels. Finally, all elements within the road safety management system, the institutional management functions, interventions, results, etc., need to be benchmarked properly against identified effective practice as we develop new projects, programs, and strategies. Now, we did speak about the National Road Safety Council, and since the council has been established in 2015, a number of really good initiatives have been proposed. And like I said, with regards to road engineering itself, there have been a number of black spot reduction programs that have been introduced on national highways especially. Road safety audits have been made mandatory for EPC and BOT projects. Crash barriers are becoming more common, especially in hilly terrains. Essential safety furniture is part of all design of roads. There are road safety annual plans with specific funds attached to it, which again is a real positive. There is a central road fund allocation for state roads, as well as there is a growing emphasis on more workshops, training, and capacity building for institutional staff. In terms of vehicle-related initiatives, there are to be no protruding rods in trucks. ABS should be mandatory for heavy vehicles. Child seat is being made mandatory in cars. Crash standards for cars are going to be introduced. So India is the world's 6th largest car market, but still the only country among the global top 10 car markets without a testing program that measures the safety of vehicles. So it is estimated that the vehicles will cost about 8 to 15% more to comply with these norms. But again, that is a cost that is negligible compared to the safety outcomes that we can achieve. Some of the other initiatives are auto headlight on for two-wheelers, specific codes for bus and truck bodies, as well as proposal for speed governors on transport vehicles. In terms of education awareness, the government is setting up model institutes for driver training and research, as well as conducting a number of other initiatives related to road safety weeks, road safety walks, and ongoing media and publicity campaigns. Finally, I think this is one very, very good initiative, that is the introduction of the Good Samaritans guidelines, which means it makes it easier for people or people who've been witnesses to road traffic collisions in order to offer help without going through lots of legal processes, as well as the initiative to set up national highway accident relief centers, which aims to provide ambulances for every 50 to 60 kilometers. In terms of enforcement, I think we've seen all of this in the media for the last 3 years. So there is the new amended Motor Vehicles Bill 2017, and also empowering state police and transport departments to impose stricter penalties on unlawful behavior. So once we have all these initiatives, etc., how do we define the success? So what does success look like for a country like India in terms of road safety outcomes? The first step would be to define what success looks like and how do we achieve the desired outcomes in terms of road safety. So different countries have taken different routes in which to measure success, and they've sort of made it a road safety slogan that they've adopted as well. So for example, Australia says safe road use for the whole community. Austria says to have a road safety level that's comparable to the levels found in the top third of the countries in the European Union. Canada wants to have the safest roads in the world. Denmark says one accident is too many. Here in the UK, we say tomorrow's roads safer for everyone. And we've gone with a vision 2040, which is zero harm as well. Netherlands has always had the very popular sustainable road safety, and Swedish Vision Zero. So depending on all of these countries that have used slogans as targets, I think we can draw inspiration from some of the countries and look at what might be appropriate and what might be achievable for India as a country in terms of road safety outcomes. Ultimately, we need to be able to define and measure performance in key focus areas. And in order to do that, we need to, first of all, set smart objectives that can be specific, measurable, achievable, realistic, and within an acceptable time frame. Again, going back to the National Road Safety Council, ever since they've been established, I think they've identified a wish list of areas that require looking at. So some of the statements that they've made are with regards to establishing a safer road safety information database, ensuring safer road infrastructure, ensuring safer vehicles, safer drivers, ensuring the safety of vulnerable road users, ensuring road traffic safety education and training is imparted at all levels, enforcing safety laws as well, to strengthen emergency medical services for road collisions, strengthening our research and in road safety functions, as well as strengthening and enabling legal, institutional, and financial environments for road safety. Now, while I do agree in principle with the key focus areas that the National Road Safety Council has identified, to me, it looks more like a wish list of measures rather than key focus areas. So in order to be able to achieve specific targets, I think we need to filter one level deeper and see what are the key focus areas, which in a sense can be quick wins that we can achieve, which can provide the best returns in terms of road safety. So it's just a proposal from my side based on experience and research that have been carried out in a number of different countries. So for example, India could look at the key risk groups in terms of drivers. So we can consider young and novice drivers. We could consider medically at risk drivers, vulnerable road users, commercial drivers, high risk drivers, and general population, etc. Not sure if you can see the graphic below. So the graphic basically shows that how our reactions slow down due to multiple activities within the car. So if we are just at the drink drive limit, then our reactions slow down by 13%. Whereas while we're using a mobile phone, our reactions slow down by almost 50%. So which means that distracted drivers, where a driver's attention is diverted from the driving task by secondary activities, can pose a huge risk to the entire road safety system. Not just that, We're also looking at impaired drivers, so drivers who are under the influence of alcohol, fatigued drivers, drivers who've been doing long, monotonous tasks without rest and proper sleep, etc. We're also talking about pedestrians, which is a new term that's come out, which is pedestrians who are always texting on their mobile phones and therefore introducing risk into the road safety system. So these are all recommendations for high-risk road users that we can consider, and India can adopt the ones that are most relevant for our conditions. In terms of interventions to reduce the risk among these high-risk groups, we will mainly talk about policy, legislation, and regulation, talk about education and training, which is, again, very, very important. So we can talk about proactive and remedial education, driver training, child restraint training, etc. Talk about communication and awareness. We need to have improved enforcement, which also includes activities carried by enforcement agencies in order to apprehend offenders and raise the perceived likelihood of being apprehended. For example, we can have check stops, selective traffic enforcement programs, intelligence-based enforcement, etc. The need for information, data, and research cannot be emphasized enough. We need to capture and compile complete, uniform, and timely data in order to expedite the identification and identification of trends and issues in road safety. We can leverage the use of technology and innovation to improve the safety of the driver. So for example, we can have systems such as alcohol ignition interlocks. We can have speed and red light cameras on the road infrastructure. We can have ESC within the vehicles. We can have side and curtain airbags, etc. And within the road system itself, we can have more of intelligent transport systems in order to ensure that the risk is reduced within the road safety environment. A second idea or thought that we could consider, which has been quite successful globally, is the application of speed management to reducing road traffic collisions. So speed management is an active approach, and it persuades drivers to adopt speeds that offer mobility without compromising safety. The safe system approach aims to achieve the road traffic system that anticipates and allows for human error and also minimizes the risk of death or serious injury due to the error. So speed management can be spoken about through a variety of measures that are aimed at balancing safety and efficiency of vehicle speeds on the road network. Very popular speed zoning, speed management methodology is through speed zoning and speed limits. So where speed limits take into account the function of the road and its environment. And it's a fundamental tool for speed management. For example, urban and rural settings will have different speed limits. The speed limits can also be governed by the mix of traffic, the percentage of non-motorized road users, and also through regularly informing the road drivers of the speed limits as well. The second aspect of speed management, obviously, is regulation and enforcement. So where we provide a legislative and regulatory setting that provides for the basis of speed compliance and measures and techniques available for on-road enforcement. This could be through speed cameras. It could be through penalties and fines such as demerit points, license suspensions, etc. Public education. Education, as you would see, will figure in a lot of these aspects because education is probably the important link that binds all of the other E's together. So in order to improve compliance and support ongoing activity, education is really, really important. So marketing campaigns, school programs, etc., are examples of education. In terms of engineering, we can think about a range of measures like school zone treatments, shopping zone treatments, busy urban precincts where we can apply public realm improvement measures. We can also look at speed humps, raised pavement sections, road narrowing, etc. So the toolbox is got a number of different types of measures that you can apply depending on its appropriateness for the particular situation. In terms of technology, we could use either vehicle technology as well as infrastructure technology. So we can use speed limiters and data recorders in vehicles, as well as we could use speed cameras, average cameras, etc., in terms of the ITS enablements on the road. And finally, this is a topic which is quite popular in Europe and UK as well, is the employer's responsibility to make sure that their vehicle fleet is compliant, safe, etc., for use by their own drivers, especially during work trips. The point that I'd like to reiterate with regards to speed management is even small increases in speeds can result in massive increases in risk. Therefore, it's better to be safe and travel within the speed limits. The next focus area could be roads and roadsides. I think this is where a majority of the engineering community comes in and we fit right in. We can talk about facilities for safer rural roads, facilities for safer urban roads. We can talk about designing safer roadsides, which removes objects or protects it with a barrier. We can have special route safety measures put in. We can have special school zone safety measures, as well as safer intersections. The bottom line with regards to providing safer roads and roadsides is the road infrastructure itself should be self-explaining, and it should be forgiving, in the sense that when a human makes an error, they shouldn't have to pay for the error through loss of life or limb. The next aspect, again, which is becoming increasingly popular globally, is the emphasis on pedestrian safety. So we need to focus on a strategy that can eliminate all traffic fatalities and severe injuries while increasing safe, healthy, and equitable mobility for all. The graphic on the left says that 100% of pedestrians might die if struck by a vehicle traveling at 70 kilometers per hour, whereas the chance of survival increases to 95% when the vehicle is traveling at 20 kilometers per hour. Now, using this as a sort of a guide, we can set speed limits and speed zones in areas depending on the mix of road use. So the mix between mobility, mix between pedestrians, not motorized users, etc. So what can we consider as measures in terms of pedestrian safety? We definitely have to consider safer walking environments. So general urban area speeds, so it's around 30 to 50 kilometers per hour. It depends on whether there is high pedestrian area, whether there are shared access areas, footpaths, home and school zones, etc. So the lower speed, it makes it more safe, it makes it more attractive, and makes it more enjoyable for people to live with good quality crossings and facilities. We can also look at implementing certain innovations in pedestrian safety with regards to intelligent speed adapters in buses and fleet vehicles, audible warning signs for pedestrians and vehicles, low speed zones or home zones, as we call it, speed cameras. And finally, there needs to be enforcement as well. And all of this, again, the measures need to come about from a properly focused research and development program and needs to be evidence-based. Some of the other kind of key focus areas that we could think about, especially in countries like India, in fact, even globally, where constant maintenance activity is happening on the roads all the time, is focus on work zone safety. Again, I think this is one of the areas where we lack quite considerably. Focusing again on vehicle safety, although this might change when we have our own vehicle testing regime. And we need to constantly keep improving our knowledge and awareness with regards to road safety and keep imparting this knowledge to the people that need it most. Now that we know what a safe systems methodology is, and we know what a road safety framework can look like, and then how a strategy can be developed using safe system methodology and identify the key focus areas. we need to be able to measure success, which is most important for the ongoing success of any road safety program. So measuring of success, we basically have 3 steps to measuring the success of a road safety program. And it could be through monitoring road safety interventions, could be through monitoring road safety performance indicators, as well as through monitoring casualties. So when you're talking about road safety interventions, we could talk in terms of road safety, road user behavior. So the number of road safety campaigns that were held, the number of road safety training activities, number of enforcement controls, number of police that have taken part in enforcement activities per day, etc. In terms of vehicle and post-collision care, we could speak about the incentives for vehicles with advanced safety equipment, new equipment for emergency services, training for emergency services staff, as well as new equipment for police forces and fire services. In terms of road infrastructure, we could talk about the number of identified high-risk sites and related interventions. Length of road sections improved. It could be just simple improvements like lighting, marking, signing, surface improvements, etc. The number and length of road safety audits conducted, the number and length of work zones that have been treated. Supporting actions for us as a research function could be the number of studies and analyses that have been taken place on road collision causes as well. In terms of monitoring road safety performance indicators, again, in terms of road user behavior, you could talk about speeding in comparison to the mean speed, speed variance, speed limit violations, etc. We could talk about the level of compliance in seatbelt usage, child restraint usage, and helmets usage. We could talk about reduction in drink driving incidents. We could talk about reduction in mobile phone incidents. We could talk about close following and inadequate headways or use of reflective devices in cyclists and pedestrians, etc. In terms of road and vehicles, we could talk about percentage of road network not satisfying the safety of road safety design standards, pavement friction, mostly in winter and in wet road conditions, percentage of new cars with stop star ratings according to NCAP, and percentage of technically defective vehicles. And finally, I think it'll all be well rounded off if we can monitor and measure the quality of post-collision care as well. And finally, the bottom line is monitoring casualties. I think most governments and most jurisdictions will be most interested in monitoring the casualties in order to determine the success or failure thereof of a road safety intervention program. And casualties could be can be monitored through the number of collisions with injuries per road type, vehicle type, road user type, etc. Number of fatalities, serious and slight injuries, including drivers, passengers, pedestrians. We could talk about risk indicators, so in terms of number of injuries per vehicle kilometers, and also severity indicators in terms of fatalities per 100 collisions, per 1,000 collisions, or whatever it is, the metric that you want to set. Finally, I'd like to end by saying that you are the most important pillar of the road safety, safe systems philosophy. And each and every one of you here has the power and responsibility to make the world safer for everyone. Therefore, road safety begins with you. Thank you very much for this excellent opportunity, and hope you found this address useful and relevant to the road safety situation in India currently. Thank you very much.
Thank you, sir. The session is open for queries, so participants may interact with the expert.
Dr. Vivian, Abhijit here.
Hello, Dr. Abhijit.
Thank you for accepting the invitation. I personally wanted to thank you. Okay. Please, can you switch on your video camera?
Yeah, will do.
Yeah. Okay.
When I find out where it is.
It'll be usually in the left-hand corner. Yeah, that's great. Okay. Yeah, that's nice. I mean, you brought back the memories of 20 years back. We were doing some black spot studies in Bangalore University on Bangalore-Mysore Road. Hope you remember.
Oh, absolutely, absolutely. First of all, let me also say that it was an absolute pleasure, and thank you for inviting me. I think I like such kind of interactions. I would have preferred it to be a face-to-face, but unfortunately, given the current circumstances, this is the best we could do, isn't it?
Yeah, this was the best thing that could be done. And you brought back all the memories of all the studies what we carried out at that particular time, and you have been working on it. And I personally thank you once again.
Thank you very much. Thank you.
I mean, if you have it, anytime you visit India, please do call us, and we'll try to make some arrangement in the college so that you can come and deliver some talks to our students.
Oh, definitely. That it will be an absolute pleasure for me. Thank you.
Yeah, thank you. Madam, if there are any questions or queries from the...
Yes, sir. There is none in the chat box. So once again, participants, if there are any queries you need to ask the expert, you can go ahead.
Hello, sir.
Hello.
Yeah, a very good afternoon, sir. I am Satyanand Sethi, a research scholar in pedestrian safety, sir, from Odisha, India.
Oh, wonderful.
Yeah, yes, sir. Actually, you have given a nice deliverance and on about the safeties and all, and definitely my party also was there, and I was grateful that to listen from you about the pedestrian safety. Actually, I want to know more idea about how to make the pedestrian safety based on the Indian roads.
So yeah, thank you for the question. It's it's an interesting question, especially coming from the perspective of the Indian road safety situation. It's all the more important. I think the first step that we need to look is see if a safe systems approach can be adopted. So within a safe systems approach, I think we talk about safer speeds, we talk about safer vehicles, safer roads, as well as safer users. And that is where I think most countries fall short in terms of adopting a truly safe system. Because a safe system will not work if the users within the system are not safe themselves. Like I said, human bodies are quite frail, and we can only accept a certain level of crash forces. And beyond that, we cannot. So I think the responsibility should start with the pedestrian. And then we can go into a number of other aspects related to technology, with regards to road engineering, etc. We need to, first of all, look at the level of pedestrian usage in that particular facility. And on that basis, I think we need to design the roads. I think far too often, I think ever since we know, we've been designing our roads for vehicles and traffic. And what that happens is consequently, there are more vehicles and more traffic, and it makes it more difficult for pedestrians. I think we need to start looking at these locations as public spaces rather than roads. And we need to start looking for people and places, which makes it safer for vehicles as well as people to interact. Because at the end of the day, even though our roads are being built for 60 kilometers per hour or 80 kilometers per hour, depending on the hierarchy, we are hardly able to achieve those speeds. And that is because of the interaction between the various modes, as well as interaction with non-motorized modes as well. So I think one of the ways that we could look at it is to reduce the design speeds itself and make the shared spaces for cyclists and pedestrians wider, and make it narrow for the vehicles, so that the vehicles can still travel at uniform speeds, but at slightly lower speeds, and still get to their destination at the same time that they would have taken at the moment.
Yes, sir. Yes, sir. Very so nice, sir. Very nice insight, sir. Then we have to particularly design as per the speed limits, the roads we have to prepare.
I would recommend that you design on the basis of the function of the road rather than the speed limits. The speed limits will be governed by the function of the road.
Okay, sir.
So if you're expecting more pedestrians, then you would have to design the road for pedestrians. Consequently, the speed limits will reduce.
Yes, sir. Thank you, sir. Thank you so much.
Any other questions? Okay, considering there are no further questions, thank you, sir. It was indeed a very informative and valuable presentation, and I'm sure all the participants do agree with me. Thank you for sparing your time in spite of the busy schedule and also considering the time zone difference between India and UK. So on behalf of Dayanand Sagar College of Engineering, I wholeheartedly thank you, sir.
Thank you very much. It was an absolute pleasure. Thank you.
Thank you, sir.
Thank you, Vivian, once again.
Thank you. Thank you, Dr. Abhijit. Thank you.
On behalf of Department of Civil Engineering and Department of Construction Technology and Management, Dayanand Sagar College of Engineering, I'm happy to propose a vote of thanks for the day. I'm sure everyone agrees with me that today we had very fruitful sessions with good technical paper presentations. On behalf of the organizing departments, I thank the keynote speaker, Dr. Vivian Robert, chairpersons, Dr. M.S. Nagkumar, Dr. Vivekar Das, Dr. Jagdish H.S., Dr. Abhijit C.C., Dr. Durga Prashant L., Dr. G.P. Shivshankar, all the speakers, delegates, participants, technical support team, and the organizing committee for their active involvement. We shall look forward to day 3 of the conference tomorrow at 10 a.m. IST, where the technical paper presentations will be from the field of environmental engineering, water resources engineering, GIS, and remote sensing. See you all until tomorrow and have a nice day ahead. Thank you.
Thank you, madam.
Thank you, sir.